Welcome to a new video of Advanced Higher Maths, and today we'll be looking at 4.3, which is going to be some more integration by substitution, but it's going to be a bit different than last time, because sometimes the SQA in the exams decides to give you a substitution you need to use. And so today we'll look at how to use that. Now you might be thinking, well, that's great, it makes it easier if they tell us what to use, but often it'll be trickier after, because it'll be more often than not trig identities that you need to use afterwards. And the thing that's quite different to what we saw last time is that now it's often going to be a simple variable such as x that we're going to solve for a slightly more complicated one, such as a trigonometric identity. So we'll look at an example, which you should be able to do yourself. It's just so you get a gist of what's going on. So you're going to be asked to use a substitution, spelled like that, x is equal to sine of theta, to find the exact value of the integral over the range 0 to 1/2 of x squared divided by the square root of 1 minus x squared with respect to x. So press pause and have a go if you think you've got it, otherwise don't worry, I'll be going through the solution. Alright, so I'll assume you've had a go. So first of all, it's telling us the substitution is going to be x equals sine theta. We don't have a choice, we can just write that down again, just to make that clear. So x is equal to sine theta. Now we need to find what dx is equal to, because we want to get rid of this dx. So dx over d theta, right, the derivative of x with respect to theta is simply equal to cosine theta, right? That's just how that works. And so dx is equal to cos theta d theta. So now we're beginning to see that we're going to be able to do something. And so what we're going to do is we're now going to substitute the data we have back into this. And so the integral, which I'm going to say I, is equal to from oh, now there's one more thing we need to change, sorry. That's what's different. We'll get rid of this. That now the limits will need to change, because the limit won't be 1/2 anymore, because now all our insides have changed. So what we do is we say that if x is equal to 1/2, then what is theta equal to, right? Because theta is our new variable. So if x is equal to 1/2, then sine of theta is equal to 1/2. Now sine of pi over 6 is equal to 1/2. So theta is equal to pi over 6, right? Because this needs to be equal. So x is equal to 1/2, and sine of theta is equal to sine of pi over 6, which is equal to 1/2. So it all works out. And we also need to match the lower bound. So if x is equal to 0, well, in this case, theta is going to be equal to 0, because sine of 0 is what is equal to 0, right? So now that we've changed our bounds, the integral is equal to, so the upper bound is pi over 6, and the lower bound is 0. And so x squared is sine squared of theta, because that's our substitution. And now, this is going to become square root of 1 minus sine squared theta, because x squared, we're just plugging in x squared, we're swapping it for sine squared. And then the dx here becomes cos theta d theta. Now, this can be simplified, thankfully, because otherwise we wouldn't get anywhere. So what we can do is, the first thing you should notice instantly is the identity square root of 1 minus sine squared of theta. Now remember, cos squared theta plus sine squared theta is equal to 1, which means cos squared theta is equal to 1 minus sine squared theta, which means cos theta is equal to square root of 1 minus sine squared theta. And here we have square root of 1 minus sine squared theta. So here and go here, and that's cos of theta. So we can just swap this for cos of theta. So we get that this is equal to the integral from 0 to pi over 6 of sine squared theta cos theta, because we're just multiplying here, oh sorry, that's meant to say d theta as well, divided by cos theta. I'm sure you'll see where this is going now, because this is equal to the integral pi over 6, 0, and the cos theta is now cancelled out. This is just equal to the integral of sine squared theta d theta. But we're not quite done. We still need one more identity, which is the fact that sine squared of theta is equal to 1/2 times 1 minus cos theta, okay? So sine squared theta, you have to be quite good with your trig identities when it comes to integration by substitution. So it turns out sine squared theta is equal to half times 1 minus cos of theta. So, and that's derived from the fact that cos of 2 theta is equal to 1 minus 2 sine squared theta. So, sine squared of theta is equal to half 1 minus cos theta. And now we don't have a squared anymore, because that's what's annoying. The squared was what's annoying. So we can say that this is equal to the integral from 0 to pi over 6. So sine squared theta, we can solve for 1 half times 1 minus cosine theta. D theta, we can bring the 1 half, because it's a scalar, we can put it outside. So this is equal to 1 half, and the integral pi over 6, 0, 1 minus cos theta, d theta. And now we can just solve this like an integral. Sorry, that's meant to be cos of 2 theta. Sorry. It's meant to be cos of 2 theta, because that's identity. My mistake. And so now we can just integrate this. So this is equal to half. Now, I'm not sure if this is in the standard integrals. It's not in the standard integral, so we have to figure it out ourselves. So we need to think, what has a derivative that is equal to cosine of 2 theta? Well, it's definitely going to be something to do with sine, right? Because the derivative of sine of theta is cosine of theta. But it's going to be a bit more complicated. Now, when we differentiate sine of theta or some trig identity, the inside stays the same. So we need the inside to be 2 theta, right? It needs to be sine 2 theta, because otherwise it's not going to stay 2 theta here. But the derivative of sine 2 theta is 2 cosine of 2 theta. So to adjust for the 2 that's being multiplied because of the chain rule, we need to put half here. So half sine 2 theta, you can check, its derivative is cosine of 2 theta. So this is equal to 1 minus, this becomes theta, minus 1 half sine 2 theta, here, pi over 6 to 0, and now you just plug in the numbers. I'm going to give myself more space, half, here, now this is theta is pi over 6, minus 1 half sine of pi over 3, because pi over 3 is 2 times pi over 6, and then minus, so theta is 0, minus 1 half sine of 0, because 2 times 0 is 0, which is equal to 1 half times, now this side, sine of pi over 3, let's draw it in a circle, or your wave, whatever you prefer, pi over 3 is here, and so sine of pi over 3 is root 3 over 2, so this is equal to 1 half pi over 6 minus root 3 over 2, so root 3 over 4, minus, so the 0 doesn't move, sine of 0 is 0, so it's actually just equal to this, which is equal to pi over 12 minus root 3 over 8. So here's our final answer to the very complicated integral we originally had. Now, I'm sure you'll understand now what I mean by it's not actually that much easier when the SQA gives us a substitution. So we're going to go through one more example that you can try and do yourself here. Alright, so you use, there's a substitution, whole page for one integral by the way. Use a substitution u is equal to 1 plus x to evaluate the integral from 0 to 1 of x over x plus 1 cubed dx. So press pause and have a go. Alright, so if we're just going to write our substitution, if u is equal to 1 plus x, then du over dx is equal to 1, which means du is equal to dx, right? And so now we can start substituting our stuff in. So, one more thing, first of all, is we have x here, but we won't be able to substitute x, but we want to substitute it because we don't want any more x's, we want everything in terms of u. And so what we do is if u is equal to x plus 1, then x is equal to u minus 1. And so the integral can be written as integral from 0 to 1 of, so x is just u minus 1. Although no, in fact, it's very important to not forget. I often am guilty of nearly forgetting. We need to change our limits as well, because remember, we can't just keep the 1 and the 0, because now we have new variables. So when x is equal to 1, which is our top limit, let's write it here, x is equal to 1, then u is equal to 1 plus 1, which is 2. And if x is equal to 0, then u is equal to 0 plus 1, which is 1. So now our new limits are 1 and 2. So the top is going to be u minus 1, and the bottom is going to be u cubed, and then dx simply becomes du. Now, from this, we can write this as, let's see, how can we simplify this expression? Well, we can write this as u over u cubed minus 1 over u cubed du. But now this can be written much simpler, so the integral is equal to from 1 to 2. Now u over u cubed is 1 over u squared, which is u to the power of negative 2. And then 1 over u cubed is u to the power of negative 3. And then we're integrating with respect to u. And so this is equal to, so power rule, you add 1, so u to the minus 1, and you divide by negative 1, so negative u to the minus 1, or you could write it as negative 1 over u. And then negative 2 it's going to become, and we divide by negative 2, negative and negative cancel, so it's going to be plus u to the negative 2 over 2. I like to keep it as a negative power, just I find it's more clean for integrals, but you could put this on the, of course, on the bottom of the fraction to make it 1 over 2 u squared. And then it's from the interval 1 to 2. And so now if we plug in our numbers, this is equal to minus 2 to the power of minus 1 plus plus 2 to the minus 2 over 2 minus 1 to the minus 1 plus 1 to the minus 2 over 2. Now minus 2 to the minus 1, that's just minus 1 over 2. And then 2 to the minus 2 over 2 is 1 over 8, because 2 to the minus 2 is 1 over 4, plus 1 over 8. Now, negative 1 to the minus 1 is negative 1, so minus and minus makes positive, so plus 1. And then 1 to the power of negative 2 is just 1, divided by 2 is 1/2, and positive and negative make a negative, so minus 1/2. And then this is equal to, so negative 1/2 minus 1/2 is 1/4, plus 1/8, so in fact let's do this all over denominator of 8, so minus 4 over 8 plus 1 over 8 plus 8 over 8 minus 4 over 8 is equal to, so this becomes minus 8 plus 8, so that's cancelled out, and then we're left with 1 over 8. So that's our final answer. So this is how you can take advantage of the SQA trying to control you to solve more complex integrals. And next time, in the next video, we'll look at how to use, finally, the partial fractions that you've spent so much time revising and studying and learning how to do. And we will see how they can be used to integrate. Dum dum dum.